Hi, we are looking at graphing absolute values. So I want to make sure that you are remembering the basics. For the equation, we have y is equal to a times x minus h plus k. So some specifics you need to remember. This is a minus, so this is the opposite sign of the h, and then this isn't. And that this value here is what makes things go, kind of what the slope, if you will. So this right here, my vertex is -5, but this one here, remember the h here would have to be a -3, so a negative. So -3 is my vertex. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, and that's going to be my vertex. And then my slope is the number in front here, and you treat it just like you normally would on the right hand side. Oops, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then it makes a V, and it has to look symmetrical. So that's what we should have. Now, let's look at this one here. For this one here, my vertex is going to be +1, because this is x minus h, so h is 1. And then k, there is no k, so it's just 0. So 1, 0 is my vertex. And from there, I'm going to do my slope. So I'm going to go rise over run, so down 3 over 4. And then I have to make it symmetrical. I have to make it a V. So I'm also going to go in that direction. So my slope is -3/4. And again, this is your -3/4, but then you have to make the V, so it has to be the same on both sides. And this one here, we would say, is upside down. So it's inverted, or upside down is fine. And it is what we say vertically compressed. So it's kind of like we went in and just kind of smashed a little bit. This one here is what we would call it stretched. It's just a little bit taller. So we're going to say vertically compressed. If you want to say it's wider, I'm cool with that. That's a good description. I like that. All right, let's look at 8. 8, do you see there's nothing with the x? So that really means it's like x minus 0. And then there's nothing out the outside of it, so it's kind of like 0. So this is actually even easier, though it looks weird, because my vertex is at 0, 0. And then my slope is at -1/2. So again, it's down 1 over 2, down 1 over 2. It needs to be symmetrical, so it needs to look exactly the same on both sides. And I want to say that this is, again, we could say wider. If we like that better, we could say it's vertically compressed. I mean, it looks like it's just something smashed a little bit there. Either way would be fine. Okay, let's go ahead and look at 2 more in this section, and then we'll go ahead and switch videos. So for this one here, we're supposed to be writing the equation of the graph. So this is 0, 0 for my vertex, and this one is -2, 0. Remember, this is your h and this is your k. So we have y is equal to a, oh, we need a, so up 1 over 1, up 1 over 1, up 1 over 1. So we have just the 1, and I don't really have to put anything in there. There's nothing with the x because that's a 0, and there's nothing on the outside of it. I'm sorry. This is not 0, 0. Oh my gosh, I'm so sorry. This is 0, -3. What am I looking at? Who knows? So this is -3. Again, that is the k. That's the part that goes down from 0, 0, which is right there. So that would be our k. Okay, so I have nothing with the x because that's a 0, and then I have -3 with the k. For this one here, I need my slope. My slope is negative. It's going down, and it is down 1 over 2, so 1/2. My vertex, this is my h. Remember, it is opposite. So important that you get that. That's really kind of the trick that you need to know. And then that's just 0, so that would be it. All right, let's just finish the rest of these here. So here, let's look at this one. Consider this graph. We want to state the coordinates of its vertex. So remember, it's opposite of what's inside there. And it is what it is out there. So this is how far it went down, and this is how far it went over in the negative. If it shifted 4 units down from here, So it's up at 3. If I go down 4, I'm going to be at -1. And if I want to be 6 units to the right, so I'm at -2, if I go 6 this way, that's going to be +4. You may want to stop and think about that in terms of where that would be. And since my new vertex is at 4, -1, 4 is what's going to go in here. So it's not 6 and 4. I want to make sure that you recognize that. That's not what happened. You have to figure out what it is, where it's moved to, and then go back in here and put it in the right spot. So it's a +4, and it's x minus h, so it ends up with a -4 there. All right, here's the last one on the front side that I'm going to look at. We have this graph. It has a slope of 3, and it passes through the point 0, 0, and 2, 0. So I want you to kind of see what's happening. I'll make this a little bit bigger. If these are the 2 points that it's going through, my V has to kind of be symmetrical about that. And since the slope is at 3, if I just kind of go here, do you notice this goes up 3/1? And then it makes the other side, the V, the same way. And then up 3/1, up 3/1. And we get our nice looking graph there. So the vertex of the graph is at 1, -3. And how do I know that? I use the slope, right? And worked backwards from the symmetry, right? So these were symmetrical, and then I can just kind of go backwards from there. Thanks for playing.